Okay, I'm going to start the geometry part of my day, and just kind of giving you a heads up of what's going on with these Zoom lessons. We're going to meet from 10 to 10:40. They only allow me 40 minutes to take video anyway, and so I'll upload those to YouTube as soon as I get through at 10:40. Things to have ready for geometry. Now, I'm just going to assume that the kids that I had this semester still have their green books at home. I required that every one of them still, have their green books. And what I mean by the green books is this right here. It should look like this cover. It should say Holt Geometry, and it has like a building or something on the front, right? So you should have, if you don't have this book, this is what we're going to use, until I figure out what I'm going to do with you guys. Other than that, I just think this is the easiest thing for y'all to connect with since you already have this, all right? If you'll notice, I'm opening up to section 9.1, all right? So I'm going to write out a few more things before I get started. Things to have ready for geometry would be the green Holt Geometry book, and then the begin in chapter 9. That's where we're going to go. First, we've covered most of the material for the year. We only had one 9 weeks left, so the majority of the material has already been discussed. That's important for these guys. And for those of you parents that are need to know some information about what I'm requiring for them to have, I'm going to treat this as if it's just like my Algebra 2 class. Also, I have them write only what I write, okay? All they are required to do is to write what they see me write down, okay? And the best way for me to grade them, there is a way for me to type in grades. Since this is the first day meeting, I'm not going to require a whole lot up front. Now tomorrow I'm going to get a little deeper into stuff, into chapter 9, and they're going to need to write a little bit more. And then by next week, they should be writing quite a bit. I mean, it should be pretty much a regular, normal class. I want to try to make tomorrow a regular, normal class, but there's a lot of upfront stuff that you guys need to know. What's happening, how to log in, how to connect with a password. I don't want any Zoom hacking stuff happening. I don't know what the security issues are with Zoom, but I'm going to make sure that they aren't a problem for me. Something about I don't know what the deal is with Zoom, but it's so useful. I'm not going to stop using it if I can help it. It says things to have ready for geometry. I need your green Holt geometry book. If you don't have that, don't worry. I'll try to make available online a digital version of it and see what I can do about that. But otherwise, just follow this video, write what I write, take a picture, take a picture of your work and upload it to Microsoft Teams. Or my email address, okay? And my email address is listed. I'll list it on I'll type it in now into the Google. If you're with me, I'll type it into the Google chat room, in the Zoom chat room. I don't want to give my email out to the entire world on YouTube, because this is not going to be the only class that watches this. There's going to be other people across the entire planet that probably watch this. So I'm going to try and adjust this accordingly, I guess. So we've got, they need the Greenholt geometry book. They need to begin on chapter 9. We're going to go through sections 1, 2, 3, until I figure out where we're going to land. I'll make sure you take a picture of your work and upload it to Microsoft Teams or my email address. Now, when I say upload it to Microsoft Teams, I mean to my class, to the class that you're supposed to be on. If you don't have other classes through Microsoft Teams, this is going to be a little bit of a learning curve for you. So you can just do this and send it to that email address I just put in the chat if you're on this Zoom. Now, if you're in YouTube, you can find me just by typing in my name, my last name, and then it should pop up, okay? So now, what are some other things? They need to have paper and pencil ready, paper and pencil or pen. It doesn't matter to me. Just don't make a lot of mistakes if you have a pen. Now, there's going to be a lot of drawing here, so there might be some tools that you'll need. You may need a ruler. I'll let you know, when you'll need a ruler. Like I'll say, I'm fixing to use a ruler now, or I'm fixing to use a straight edge, and then I'll kind of give you a heads up on that. All right. It's hard to teach geometry without some kind of straight line. So now, if they have any calculator will work. I'm using a TI-84. That's Texas Instruments 84. You don't have to use that. It looks like the one I'm going to be using looks like this. It's a TI-84 Plus, actually, but it doesn't matter. But it's that standard calculator that everybody uses as far as colleges and things like that. Now, so look at your list of what you need to have ready. Have it ready before you get to me. Now, a lot of you are probably not going to be able to join up today because it's a little bit of a learning curve with this Zoom thing. And I also gave y'all very little warning that this was going to happen today. So most of y'all should have figured out by tomorrow and be able to join in. Now, here's my deal about Zoom. You do not have to watch the Zoom lesson as it's happening. You can wait until I upload it to YouTube, which is going to happen at 10:40, and then you can watch it anytime at your own leisure. All right. I'm not requiring that you're a part of the classroom. I guess this would be considered the classroom, but I want you to know that you need to complete the material so that I can upload it. I mean, I can type in a grade for you. Now, here's the deal. How am I going to know that Johnny's sending me his picture of his work, and Joseph is not just taking it and copying it? Well, I guess anything's possible, right? So I'm trusting you. Okay. I'm putting myself out there by teaching this material. And I want you to grasp this on your own. Is it possible for somebody to cheat and send in something? Well, I'll probably catch it. And if I do, it's going to hurt. So be aware. Okay. That I'll know if somebody's copying something. Okay. I know most of you guys handwriting by now. Okay. So I've graded enough papers to have figured that out. And parents that are listening to this, I'm trying to be realistic, and I want you to just do your part, do your due diligence and make sure that the students, kind of watch what they're doing and verify it before it gets sent. All right. So let's move on, just like a normal day would. I'm going to start off with section 9.1 in the green geometry book. Now I'm going to go back in my to the very beginning of chapter 9, and I want you to see kind of an overview of what's fixing to happen. Okay. All right. So now with this format that we have here, there's a lot of things, a lot of leeway that I can take as far as doing things, outside, outdoors, and maybe discussing things that I see around that would be pretty interesting. There could be times when I might think, hey, it might be good to show you something that I've seen that's around my home that would help me explain a topic or But so let's look at this and see what's happening here. So we're going to talk about the first part of chapter 9 is going to be dealing with formulas for triangles and quadrilaterals, then formulas for circles and regular polygons. We're going to focus in on those two sections mainly. Composite figures, we might get into that here in a little bit. But the next section, this will probably be this week here, and this will probably be next week, okay? This is my heads up for y'all. So let's pull this down. So we've got 9.4, we'll start talking about probably next week, perimeter and area in the coordinate plane, and 9.5, changing proportions. And now I'm not sure I'm going to get to this geometric probability. I think I may skip out on that, okay? So now the pacing for a 45-minute class, we're trying to, focus in on and spending only about 40 minutes a day. So day 1, here's kind of my overview of what's going to happen, just to close that, to cancel out that 9.6 there, that last section there. So the next couple of days is going to look like this, okay? So we're going to start here at this day, and we'll probably wrap up 9.1 tomorrow. Then Wednesday we'll start 9.2, and then move on from there. Okay. So let's come over here and look at a few things. All right. Now I am going to try to incorporate every day for geometry some kind of ACT problem at the very end. And the last thing you'll see before I leave you is an ACT problem. And I want you to try it before you see me the next day. So when you see this book right here pulled out, this ACT book, when you see this pulled out, and if I open to a specific page, like let's say here, if I zoom in on this little section right here, this is the problem that I'm going to expect you guys to have practiced before. Now, this one specifically, not today, but I'll have a problem like that pulled up, and then I'll begin the next lesson discussing that ACT problem, okay? And so I'm going to try my best to incorporate ACT if possible. Now, just kind of as a heads up on how fast this class goes, we're already 16 or 17 minutes into the lesson, and I only have 40 minutes. So let's kind of hit the high points real quick, and then we'll get into what we're supposed to learn. Okay. So now I apologize for any things that are hard to see or whatever. I'll try and clear stuff up as we go. But geometry is a very visual form of math. And so you're going to need to do a lot of out of the box thinking. Okay. So when you see, like if you were flying over this little area here in the mountains, you would notice that you've got a bunch of little sections here that are mapped off. You've got an area of trees, an area cleared off, an area of trees. So somebody, some surveyor or civil engineer mapped this out. And if you'll notice, look how neat and precise everything is. they were able to use through GPS coordinates, just like on your cell phone, exactly where these things are located. Okay, and it's important that you understand in the real world, area and circumference are huge. They are really important because there's money involved here. Okay, perimeter, area, circumference, and area. This is the three things that we're learning about in chapter 9. Okay, so now we're going to go look at, now my version of the book is the teacher's edition, and it's got all the answers in it. Okay, so I'm going to pull this over here, and I'm going to look at this "Are you ready?" section first. Now we're going to talk about some vocabulary. All right. So let's look at this vocabulary real quick and kind of go over the high points of what we're supposed to learn today. And I'm going to kind of discuss some things with you next time I hear from you, which is tomorrow at 10 o'clock, about these four definitions here. Okay. So the area, what does that mean? Area is the number of non-overlapping unit squares of a given size that exactly cover the interior of a figure. Now, I don't want you to write this down right now, okay? I just want you to kind of listen and follow me as we go. So we've got the area is the number of non-overlapping unit squares of a given size that exactly cover the interior of a figure. Well, if you'll go back over here to this little plot of land. So non-overlapping squares, what are they? I'm getting a message from one of my students. Hold on just a second. Messaging, they're having trouble logging in. So give me just a second. Okay, so just message that student that they're having trouble logging in. I might be able to figure out how to get them to sync up to me, but I just told them to be patient because I'm going to upload it to YouTube, and I don't know what's going on with that. So anyway, so let's go over here. So now this is the area, the plot of land that we have here. If you'll notice, these are non-overlapping squares. So in other words, it's like, crossing over into the other square. So if you went and counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, this little section right here would be 15 square feet or square acres or whatever, okay? Because each one of these is a square acre, okay? And so now let's move over and talk about so that's area, okay? And a kite, what is a kite? Now, you've flown a kite in the air before, most likely. Some of y'all have at least seen it, all right? So a kite is a quadrilateral. A quadrilateral looks like this. So we've got a quadrilateral. So here's a parallelogram or a quadrilateral. Here's another parallelogram, which is a square. Here's another parallelogram, because they're parallel on opposite sides here. So those two sides are opposite. So that's a parallelogram. And then we've got a kite that looks like this, okay? Kite looks kind of like this. So we're going to draw a line here and draw a line there. So that's what a kite is. And it's a quadrilateral with exactly 2 pairs of adjacent congruent sides. All right, so two pairs of adjacent congruent sides. Adjacent and congruent are two different kinds of words. Adjacent means next to. So we've got, let's pull this down. So these two right here, these two sides are adjacent to one another because they share a common endpoint, a common vertex, and they're congruent, right? So those two right here are congruent. So if you were to look at that, that's one set of adjacent congruent sides. Then you look over here, we've got another set. These are different lengths here. It's two sets of adjacent congruent sides. So we've got, obviously, these two are also adjacent because they share a common side. But that's not what we're talking about here. We're talking about something that's congruent. So these two are congruent and those two are congruent. All right, so that's what they're saying when they mean those words here. So perimeter, let's talk about perimeter. If you were to walk around this little area here, this would be one stretch of land there, one stretch of land there. If you walked around the entire forest, if this was your walking trail or your running trail, that would be what's called the perimeter. Now notice, you're not getting out in the middle where the trees are. You're staying on this path along the outside. So that's, think about the path around a shape, and that's going to be the perimeter, okay? So the regular polygon, what is that? Regular means it's all the same sizes on each side, and then polygon means many sides. So let's see what the definition actually is. It says a polygon that is both equilateral and equiangular. All right, now let's discuss that. Refresh those words in your mind. Equilateral would be like a square. A square is equilateral on the sides, equal sides, and then equiangular would be all the angles are equal. In this case, if you write it like this, all these angles would be 90 degrees. So equal angles. Now, remember, in order for it to be a regular polygon, it has to be both. It has to be a polygon that is both equilateral and equiangular. So you got to have equal sides and equal angles for it to be a regular polygon. All right. Now we're going to start getting into some real notes here. Okay. So what does Mr. King want you to actually write down? All right. So this is what I want you to write down. So get your sheet of paper ready. And this will be your first day's worth of notes. Now remember, we only have 40 minutes. So that means we have 15 minutes to take notes. All right. Left. So it's 20 or 25 minutes in. Now we're going to talk about the parallelograms, triangles, trapezoids, rhombuses, kites, all the above. All right, we're going to discuss all these little things here. And circles, we'll get into that soon. And regular polygons, we just talked about, have equal sides and equal angles all the way around, okay? Now there's a lot of formulas going on here, so don't stress over that. Not a big deal. We'll just take it each point at a time, and we'll discuss how each one works. The easiest one to remember on area is length times width or base times height on a quadrilateral or parallelogram. All right, so these are if you have your book, this is page 588. Keep going, 588B, I believe. Is that what it says? Yeah, it's 588. I don't know. So that's you may or may not have this in your grade book. I'm not sure, but we're going to need it for lessons 9.1 and 9.2. So I may print that off and then post that or something. So, all right. So let's go over here and look at what's important. We're going to focus in on is the examples and anything that's in this yellow area right here and this area. So these sections here and the examples are what we're going to discuss all the way through this lesson, okay? So that's what I'm going to expect you guys to write down by hand is those little parts. So I'm going to pull page out so y'all can see what's happening here. Okay, so now we're going to start off with postulate 911. All right, so we need to put a little dot here, and we're going to write out area, addition, postulate. Now, postulate means you cannot, or it has not been proven yet. It's not a theorem because you're dealing with things that do not exist, like lines or points or rays or things of that nature. So set line segments, those do not exist in reality because a line is infinitesimally small. So let me see if I can say that right. Infinitesimally small. So it's so small, a line is not this. A line is smaller than this. It's thinner than that. It has no thickness at all. The tip of this pen has a thickness, has a width, right? So anytime I try to draw something here, it's not going to represent what a line actually is. It's going to be a visual representation of what it looks kind of like. So a line is not just a slit. It's very small. It's so small you can't even see it because it's made up of little bitty points like that all along the line, okay? So now we're going to write the area addition postulate and take your time doing this. Make it neat, all right? The area of a region is equal to the sum of the areas of its non-overlapping parts. Okay, so just to hit that again, as we're going to talk about, you see all this little origami little shape here. You got different parts, different shapes here. These are non-overlapping. So if I were to find the area of this, you've got a pink square, red square, pink square, red triangle. Parallelogram, pink triangle. So you get the idea. So you add the areas, which going back to those little trees that we saw earlier, the area is the part of the basically inside here. So if you were to look at this as an entire field, the area is all of these squares. It's the inside of this field. You got all these little squares here. You count all those little squares inside there. So if you go back over to this little section, if you had little squares drawn inside of each shape, you would count each little square inside the shape and then add that to all those squares and all those squares. So this is what the area addition postulate is, okay? So let's move down to the next section. So we're going to talk about the area of a parallelogram. All right, so area of a parallelogram. Okay, so what is that? It's area equals base times height. So the words here are base, B, and height, H. And so to draw an example here, so this is where you would pull out a straight edge if you want to make it nice and neat, but I'm not that worried about it at this point. We'll get into the neat stuff later. So remember, the base and the height have to be separated by a right angle. All right, you can't just assume that this length is the height. It has to be straight up and down, and the base has to be left and right, horizontal. Now let's go in and work on a few other things. So we're 32 minutes in, so we've got about 8 minutes left. We'll do an example, and remember, I'll finish every day with an ACT problem. Okay, so we're going to work out this example. Well, let's read through it real quick. It says, find each measurement, the area of the parallelogram. You remember the formula. the formula is area equals base times height, okay? Do you see the base? How big is this base? All right. The base looks to me like it's 6 inches in length. All right. Now, this 6 plus 3, this 3 over here, this is just an extension. This is not part of the shape. So what you would say, the shape itself is 6 on its base. The height would be from here to here. Now, how would you calculate for that height? So what we'd use is the Pythagorean theorem to find the height, okay? So let's go back and work this out. So example 1. So Mr. King wants you to have, I'm going to pause this right here for just a second. I want you to write all of this out, okay? And then take a picture of it and upload it. That's what I need for y'all to be able to show that you are following me, okay? So if you get to this point, just pause the button on your video and write this stuff down and then take a picture and send it in. Now it has to be in your own handwriting and you're following me, okay? So now we're going to start off with a shape. Now this is not drawn to scale. Getting buzz here. Let me see what this is. Okay. All right. So let's pull this out of our hat here and notice that we've got a parallelogram. So that means this side and this side are parallel. This side and this side are parallel. Okay. So in this case, this is 6. Did they say inches? Yes. So I'm going to put 6 inches there. They said that this length here is 5 inches. Now the answer is not 6 times 5 because this is not a, you remember your height is supposed to be exactly perpendicular to the base. So we don't know what this height is. So what we can do is we can take this and move this out and extend it down like that and say, okay, well, these two little dotted lines are the same length, okay? Now, they give me that this little section is 3 inches, okay? Now, if you'll remember in geometry, there are special right triangles. Special right triangles. I'm going to write those out. So special right triangles would be a 3, 4, 5, 6, 8, 10, 5, 12, 13, and so on and so on and so on. So what we're going to work on is this 3, 4, 5 triangle. Now, this is something you can memorize here because any triangle that has 3 and 5 on it for the hypotenuse would have to be a 3, 4, 5 triangle like this because it would follow by the Pythagorean theorem. All right. Now I am going to work out the Pythagorean theorem here, but I wanted you to know that there is a way to do this in your mind if you memorize this stuff. All right. So let's go over here and look at this. We've got a shape that has a base of 6 inches. Okay. And then we have a height that we don't know. Okay, so now we're going to take this little section right here. I want you to shade this little section in. And we're going to write out the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Okay, all right, what does that mean? That's going to be A can be your shortest length if you want to think about that. You can be the shorter length. Now the longest length, which is your C, is going to have to be 5 here because the hypotenuse of this triangle is the longest length. So C would be 5 in this case. And what I'm trying to find is the other length, the middle length, or so on. So 3 squared is 9. B squared stays B squared. And 5 squared becomes 25, okay? So now, all you have to do is subtract 9 from both sides and solve for B. Solve for B. Now, in this case, this is tricky because B could also stand for base, but that's not what we're looking for here. That's going to be what's confusing is A, B, and C are the lengths of your triangles. B is not this B, okay? B is just a letter that they chose to represent the middle length here, okay? So we've got B squared equals 16 when we subtract that. Now we need to square root. So we're going to square root B squared and square root the 16. And square roots cancel squares, and we have the answer is B equals 4. So in other words, your height is 4 inches. All right, so now, are we through with this problem? No, we are not through with this problem. You need the area, okay? You need the area. So what's the area? And it's equal to base times height. All right. So make sure you're writing this out. Pause the video if you're too far behind right now. And now come over here to the right, and we're going to write down area equals base times height. So area equals the base, which is 6 inches of that figure here. And then the height, what we just calculated, is 4 inches. All right. And so what happens here, remember a while ago I had that picture of all the squares across the entire area of that field. Well, that's measured in squares. Those are acres squared. So in this case, we have inches squared. How many inches squared? We have 24 inches squared, okay? So that's the area of the parallelogram. And now we have 1 minute left. So I'm going to pause the video. Let me show you what I expect you to have written down. So this is your notes for today, okay? If you want to zoom in on this, you can zoom in. This is what I expect y'all to have written down and sent in to me. Now, you're going to need to put your name up here at the top, okay? Put your name at the top. And you can put the date if you want. My date is 4/6/20, okay? All right, so pause the video right here, write this down, and send that in to me. Now, I'm going to show you an ACT problem I want you to attempt for me tomorrow, okay? We're just going to pick a random one, all right? I want you to try this one right here, okay? All right. Now, that's the thing about ACT problems is they are randomly selected. They're not in order. They're not organized very much, and they're just thrown at you, okay? I want you to try this problem right here. All right, so pause your video, get it completed, and I want the answer to this problem tomorrow when you come back.